In this video, we're going to look at a problem involving some prime factors, and the problem is this. 5,681 has got 3 prime factors. What are they? To start off with, let's have a look at some numbers that it could possibly be. So if we think of prime numbers which are small enough to be a reasonable size, we could have 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on. And what we like to do is to go through this list, we can filter some out and see which numbers are left over at the end. First of all then, let's also create a prime factor tree. This is going to help us think about some numbers that could or couldn't work. So we've got 5,681. Because we've got 3 prime factors, we know that our tree is going to look like this. Can split into 2 first, and then one of these numbers is going to be prime. The other one's going to be a composite number, so that can split up into 2 other prime factors. We'll be left with 1, 2, 3 prime factors. Let's start on our list then and see which numbers can and cannot work. Well, 2 definitely can't be a factor of this number because 2 is even and our number's odd. So let's get rid of 2 straight away. If we're thinking about 3, well, there's a really good test for divisibility by 3, and it's this. If the digits of the number, so 5 plus 6 plus 8 plus 1, if those digits sum to a multiple of 3, then our number has to be divisible by 3. Well, 5 add 6 is 11, add 8 is 19, add another 1 is 20. That's not divisible by 3. So we can say that our number, 5,681, cannot be divisible by 3. 5 is a really easy one to check because it doesn't end in a 0 or a 5. So let's get rid of 5. There's a divisibility test for 7, but it's a bit more complicated. I think I'd rather just do this one this way. So dividing by 7, if we think of a number we know is divisible by 7, so take 5,600, which we know is 800 times by 7. And to get from 5,600 to 5,681, we would have to add 81. If we're thinking about 81, well, 81 is not divisible by 7. And we can write that like this. A vertical line and this diagonal line through it means 81 is not divisible by 7. So 5,681 is also not divisible by 7. Okay, next we go to 11. And for 11 there's a nice divisibility test. So if we write out our number 5, 6, 8, 1. To test if a number is divisible by 11, what you do is you take the odd digits first. So digit number 1 and digit number 3 in this number, there are odd digits. You add them up. So 5 and 8 will get us 13. Then we look at our even digits. So even digits, I'll do those in a different colour. And with our even digits, we also add those up. So 6, add 1 to get 7. We would be looking at the difference between the sum of the odd and even digits in our 11 divisibility test. And this number here, 13 take away 7 is going to be 6. If a number is divisible by 11, the difference between the sums of the odd and the even digits will either be 0 or itself be a multiple of 11. This is not either of those, so 11 is definitely not a divisor of 5,681. Next we can try 13. So let's have a look for 13. And if we think of some numbers that we know are divisible by 13, well, I know that 13 times 400 will be 5,200. Let's add on another multiple of 13 because we're just thinking in 13 times tables here. So 13 times 40 is 520. When we add these up, we see that 13 times 440 will be 5,720. This is good for us because it's quite close to our 5,681. Can we get from 5,720 to 5,681 using only 13s? And yes, we can. If we do 13 times 3, that gets us 39. And we can take this row, the second row, away from that top row. So 13 times 440, take away 13 times 3, will be 13 times 437. And likewise on the right hand side, 5,720 take away 39 should get us 5,681. What that tells us is that 13 is definitely a divisor of 5,681. So we can put a box around it. And actually that means 13 has got to be this number here at the moment. So let's put that in there, 13. But we get some more useful information from this, and it's the 437. That can be a number that goes in here. And 437, the good thing for us is that any number that goes into 437 must also go into 5,681. This is a really nice visual representation of this idea in number theory that goes like this. If a prime number divides some number a, so p divides a, and a divides b, so if our prime number divides 437 and 437 divides 5,681, then we can say p divides b. So any prime that divides this number must also divide that number. Okay then, let's work with 437, and because of this idea we can skip the prime numbers we've already tried and just start from 17 and carry on there. Let's go for 17 then, looking at 437. So for 17, what numbers does 17 definitely go into? Well, we can do 17 times 20, which gives us 340. Let's think of another multiple of 17 that we know. So 17 times 5, which is 85. And if we take the sum of these two, we get 17 times 25 is 425. Well, if we know that 17 times 25 is 425, and we're looking for 437, just trying to see where it went there, 437, there's no way that, because the difference is only 12 between these two, there's no way 17 can go into 437. So we can get rid of 17 as a potential divisor as well. Moving on to 19 then. Hmm. 19 going into 437. If we think of some numbers that we know 19 goes into, well, 19 times 20 will be 380. That's good, we're getting kind of close to 437. Think of another multiple of 19 we know. And this one is a good one because it ends in a 7. So 19 times 3 gives us 57. It's 3 less than 60. If we we add this row to the row above, we will end up with 19 times 23, and that will give us 380 plus 57 is our 437 that we are looking for. Notice as well that we've actually just found 2 prime factors in one. We found the 19 that we were actually investigating, but we also found the 23, which is the other prime factor that has to multiply with 19 to make this number. So we've killed 2 birds with 1 stone here. We found 19 is a prime factor, and 23 is another prime factor of 437, and therefore 5,681. So let's add in 19 and 23. We've solved our problem then. The 3 prime factors of 5,681 are 13, 19 and 23. They give us our original number 5681.